Today we're going to talk about solving rational equations. And in order to solve a rational equation, you must find a common denominator first. Even though we find a common denominator first, we cannot forget about the restrictions of x when dealing with rational equations. Let's take a look at example number 1. 5 over 2 plus 3 over x equals 16 over 2x. I understand that in the second term we are dividing by x. Well, if we're dividing by x, we can never divide by 0, so my first restriction is that x cannot equal 0. Now that I've identified our restrictions, we need to find a common denominator. I can see that in all three terms, the common denominator would be 2x. So I have to ask myself, what can I do to terms 1 and 2 to make the denominator be equal to 2x? Let's deal with term 1 first. What can I multiply 5 over 2 to get to 2x? It looks like I can multiply 5 over 2 by x over x. And when I do so, you get 5x over 2x. What can I now do to term number 2 to get to a common denominator of 2x? Well, it looks like I can multiply the second term by 2 over 2, which then would give me 6 over 2x. And I didn't change the third term, which is 16 over 2x. Now looking at my new equation with a common denominator of 2x, I can see that all three terms have the common denominator of 2x. Now that I have a common denominator of 2x, I can now solve the equation that is simply on the numerator, which is 5x plus 6 equals 16. Well, let's solve for x using our algebra skills. To solve for x, I need a minus 6 from both sides. And you get 5x equals 10. I need to solve for x, so I need to divide by 5 to both sides, and you get x equals 2. So x equals 2 and x cannot equal 0 will be your final solution. Let's now take a look at a second example. Let's now look at the second example. Looking at the denominators, we need to find the restrictions of x. But in order to make things a little bit easier, let's try to factor this third term's denominator. And when we factor that, I believe x squared minus 1 is the same as x plus 1 times x minus 1. And so when we rewrite my equation, it would be 3 over x minus 1 plus 5 over x plus 1 equals 14 over x plus 1 times x minus 1. Looking at the equation now in factored form makes it a lot easier to identify our restrictions of x. What values of x would make the denominators equal to 0, because we know in math we can never divide by 0, so therefore these are the values that x cannot equal. Well, x cannot equal positive 1, and x cannot equal negative 1, because these are the values that if I was to plug into this equation, the denominators in the first term and in the second term would be equal to 0. And these are our restrictions of x. And now that I've identified my restrictions, we now need to find our common denominator. Well, looking at this equation, I notice that the common denominator would have to be x plus 1 times x minus 1. Well, I need to ask myself, what can I multiply the first term by, 3 over x minus 1, to get a denominator of x plus 1 times x minus 1? Well, I can now multiply 3 over x minus 1 times x plus 1 over x plus 1. When we multiply fractions, we multiply straight across. So I need to distribute the 3. And we get 3x plus 3 over my common denominator of x minus 1 times x plus 1. But what can I now do to the second term to get a common denominator of x plus 1 times x minus 1? Well, I can take 5 over x plus 1 and multiply by x minus 1 over x minus 1. And we multiply fractions straight across, so I need to distribute the 5, and we get 5x minus 5 over our common denominator of x plus 1 times x minus 1. Well, now I can rewrite my equation with my two new terms with a common denominator of x plus 1 times x minus 1, and we see that we get 3x plus 3 over the common denominator plus 5x minus 5 over the common denominator equals 14 over the common denominator, which we all know is x plus 1 times x minus 1. Now that I have a common denominator, I can solve the equation that is in the numerator, which is 3x plus 3 plus 5x minus 5 equals 14. This is where we use our algebra skills to solve for x. Well, we can combine like terms, and we get 8x minus 2 equals 14. I add 2 to both sides, plus 2, and you get 8x equals 16. Divide by 8, and x equals 2. Well, x equals 2, but we can't forget what we first did, which was identify the restrictions of x. And so x equals 2, and x cannot equal to 1, and x cannot equal to negative 1 would be your solution. Let's take a look at one more example. Now, looking at this third example, let's continue to do what we did in the previous two. The first thing we did was identify the restriction. Well, I know that we can never divide by 0, so what values of x would give me a 0 in the denominator? And I can recognize that the only value that I can have for x would be x cannot equal 0. Once I've identified that restriction, we now need to discover our common denominator. And looking at these three terms, I notice that the common denominator across all three terms would be x to the third. So we ask ourselves, what can I do to this first term, 1 over x, and what can I multiply this by to get to x cubed in the denominator? Well, I would have to take 1 over x and multiply by x squared over x squared. And we multiply fractions straight across, so I end up with x squared over x cubed. But what can I now do to the second term, which is 5 over x squared? And what can I multiply this by to get to x cubed on the bottom? Well, I would multiply by x over x, and we multiply fractions straight across. So we get 5x over x cubed. Well, I now can rewrite this new equation with my two new terms that now have the common denominator of x cubed, and I'll have a new equation of x squared over x cubed plus 5x over x cubed equals negative 6 over x cubed. And now that every term in this equation has a common denominator of x cubed, I can rewrite the new equation of the numerator, which will then be x squared plus 5x equals negative 6. And I need to use my algebra skills to solve for this equation. But I need to recognize that this equation is a quadratic equation because we have a highest power of 2. And what is the first step in solving a quadratic equation? Is to set this equation equal to 0. And right now it equals 6. So in order to set it equal to 0, I need to add 6 to both sides. And then I'll get x squared plus 5x plus 6 equals 0. Well, I've set it equal to 0, and now I know I need to factor. I want to know what two terms times each other is equal to 0. But to get from standard form to factored form, I know I need to go through the box method. And I know that in quadratic equations, the first term of x squared will always end up in the top left. And I know that the c term will always end up in the bottom right. And we ask ourselves and we work backwards. What times what gives you x squared? And we all know that the only things that multiply to x squared would be x times x. And we're halfway there. But we now need to find out what two numbers, this number times this number, multiply to positive 6. But we can't forget that this box plus this box have to add to a positive 5x. Well, what two factors multiply to 6 but also add to 5? 3 and 2. And 3 times x gives you 3x. X times 2 gives you 2x. Does 2x plus 3x equal to 5x? It does. So I factored correctly that x squared plus 5x plus 6 is the same as x plus 3 times x plus 2 equals 0. But I still have yet to find what x equals. Well, now that I've changed my standard form equation of a quadratic to factored form, I now can take my factors and set them equal to 0, and we get x equals negative 3 and x equals negative 2. But we can't forget about the one restriction, which is x cannot equal 0, and this would be your solution for this rational equation. Now, let's practice on your own.